Hello, everyone, and welcome. My name is Eric Franzen, President of SemanticWeb.com. We would like to thank you for joining us today for this webinar, a joint production between Dataversity and SemanticWeb.com. With our speaker today, Arnaud Laors of IBM. Today, Arnaud will be discussing getting started with the Linked Data Platform, otherwise known as LDP. Just a couple of points to get us started. Due to the large number of people that attend these sessions, you will be muted during the webinar. For questions, we will be collecting them via the Q&A section in the bottom right-hand corner of your screen. Or if you like to tweet, we will be looking out on Twitter for hashtag SemanticWeb. As always, we will send a follow-up email within 2 business days containing links to the slides, the recording of this session, yes, we are recording today, and additional information that might be requested throughout the webinar. Without further ado, please allow me to introduce to you our speaker today, Arnaud Laors. Arnaud has been working on open standards for over 15 years, both as a staff member of standards development organizations such as W3C, and also as a representative for IBM. I will let him speak more about his background, and without any further delay, Arnaud Laors. Welcome, Arnaud.
Thank you, Eric. Well, thank you all for joining today. I'm impressed by the number of people who already joined at the top of the hour, and some people had even joined much earlier. Thank you. Well, I'm glad you're interested in LDP. I think this is an important specification that will allow us to take better advantage of the stack of linked data standards that came out of W3C. And so I think this is a good, I hope you will find it a good investment of your time. So as Eric said, I mean, I have been in the standards development business for quite a while. Most of my career at this point I have dedicated to developing standards. I'm known to have been involved in many of the key web standards, such as HTML itself, and but as well as DOM, XML. I had some of my fingers put into CSS at some point, and more recently I've been focusing on linked data standards, and so I am right now the lead for linked data standards at IBM. So let's get to the actual meat of the presentation, which you probably came for rather than my background. So I first want to talk about linked data because, and this is part of the point that brought LDP, as I will explain later, there is a lot of talks about linked data, but there isn't much clarity as to what linked data really is. And quite frankly, there is also some controversy, and I'm not trying to, say who is right, who is wrong, but I think it's important to define what I talk about when I say linked data. So we'll then talk about how we use linked data for application integration, which is a different type of use that is typically that linked data is known for. And then I will talk about some of the challenges that you may encounter in trying to use linked data in such a way. And then that will bring us to the W3C linked data platform, which is the upcoming W3C standards that addresses some of these problems. And then I will finish by talking about some of the related projects to LDP that are going on and some final words. So as an introduction, I also want to try and position what this presentation is about. I'm not going to get into the gory details of the specification that's coming up, and rather this is more of a positioning of what LDP is for and how it compares to other linked data related specifications. There will be a presentation, and I'll talk about that at the end. There will be a presentation at the SEMTech conference in which I will get more into the details of the specifications. So with that, let's start with the linked data definition. So as far as I'm concerned, I take linked data, from the definition that was led by Tim Berners-Lee in 2006. He put on a web page a set of 4 rules in which he described what he coined as linked data. The basic idea is, so here, the 4 bullets are here. I'll read them because it's pretty short. So the first principle is use URIs as names for things. Second, use HTTP URIs so that people can look up those names. And then 3, when someone looks up a URI, provide useful information using the standards, and that includes RDF and SPARQL. And then 4th, include links to other URIs so that they can discover more things. And it concludes this with simple. As I said before, there has been a lot of controversy about exactly what happened there and how, it was edited over time, slightly changed. It's important to note that this is not an official document from W3C. This is a web page. Tim Berners-Lee has a bunch of web pages in which he posts on different topics that he cares about. And this is just one of those pages. What's interesting to see, moving on slide 5, is how the 4 principles that he has laid out are actually completely in keeping with the architecture of the web of documents the way we know it. If you think about it, the web of documents has 4 different key elements. The first one is there's a mechanism to have standard global identifier that also serves as locator. So these are the URLs that we all use that you put in a browser to go to a page with your browser. There is a standard access protocol, which is HTTP, which allows the browser to connect to the server to retrieve the page. There's a standard representation. In the case of documents, we use HTML so that the browser can actually interpret the document that is being sent and display it accordingly. And finally, we use those URLs that are being used to identify the pages and to be able to locate them to link between pages. These are the tenets of the web. And when you look at the 4 principles that Tim Berners-Lee, not surprisingly, it follows very much this model. So the first element, he says, use URLs to name things, also to access them. He's reusing HTTP to access the information. The only difference is now we need something that is broader than HTML, that does not allow just to, HTML is really targeted for pages, documents, textual documents. Now we need something broader, and he proposes to use RDF, which allows to represent any kind of data. And then he uses the same principle of hyperlinks to link different pieces of data that are related. So, people have had different interpretations, and there's been a lot of controversy as to what really was meant. But when you think about it, it's super simple, and it's in keeping with the way he has designed the web in the first place. So I think it's fair to make, to see it that way. So moving on, there are many different specifications that have been developed over time by the W3C that are related to the semantic web. And there was a name change in the way, and it has led to more confusion. What is linked data? What is semantic web? Some people say they are the same. Some people say, well, one is part of the other. It doesn't really matter. But I think there is a convenient way to try and classify the different specifications that have been produced by the W3C. The W3C started that over 15 years ago now. And so there's a whole series of specifications, and I'm not even trying to list them all here on this slide, but I'm trying to give an idea of the main specifications in which category they fall in. So the protocol I talked about, HTTP, the data model is RDF, and then there are several serialization formats for the data model. That's an important thing that a lot of people miss in the beginning. They don't understand that RDF is not RDF XML. RDF is a data model. And to make that point very clear, the W3C has now produced several other serialization formats that should clarify that point very strongly. There are different ways you can serialize the data model. And so RDF XML was the only format for the longest time. And when people talked about RDF, they loosely thought about RDF XML, and there was a confusion as to really what RDF was. And I think there are a lot of people who didn't like RDF XML. The way I like to describe it is because RDF is a graph, and XML is a tree structure. So trying to fit a graph into a tree structure is not very convenient, and it gives a result that's not very pretty. It's kind of trying to have a 3D model into a 2D representation. It's hard. So there are other formats that have been defined for different purposes. Turtle is probably the most common in the RDF community today because it's very easy and human readable. And I claim that anybody who hasn't really looked into RDF before, they should start with Turtle because that makes it super easy to understand. And I have to say, I'll share my personal experience. When I started many years ago looking into this, I looked at RDF XML and I was like, oh my, what is this thing? And then you look at Turtle and you're like, oh, that's what it is. And so I highly recommend to start from there. And then there are other formats. Trig is for data sets, so you can compartmentalize the data. And there is RDFA, which is a serialization format to embed RDF data into HTML. JSON LD is becoming a very popular format for RDF because of the popularity of JSON, and it allows you to represent RDF in JSON. Then there is an important specification called SPARQL, which allows you to query RDF databases. And it's essentially SPARQL is to RDF what SQL is to relational databases. And then there is a list of other specifications. One I've put in the category of ontologies. RDF schema and OWL are the primary ones. But there are other specifications to bridge different technology like RDB to RDF, which allows you to define mappings between a relational database and RDF in different ways. There are actually two different ways. And there are other specifications. So what I think is important to get from this is not so much, the exactly which spec is out there, but try to to understand that there are different high categories, and you don't actually need to use them all to make use of linked data. And the way I sorted it, I have a bias, is that I claim that you can use the basic layers, the three first categories, protocol, data model, and serialization format, to do a lot of really good things already. And then you could use query is probably the next thing you want to use. The key is, if you start looking at how most, the average application developer is going to start scratching their head saying, what, ontology? What is an ontology? They probably don't even know that. So it's useful to know that linked data and the linked data platform specifically does not rely on using any of these higher level technologies. At the same time, you have a big advantage of using linked data because those higher level technologies, they are available. Once you build with the basic layers, you can always add on top of it things to have richer features, such as, inferencing, reasoning, all these good names, but you don't have to worry about that up front. So moving on. Linked data, the linked open data. There is also a lot of confusion between what linked data is and the linked open data movement. A lot of people think or talk about linked open data. They use casually the term linked data. And in fact, if you go to linkeddata.org, you'll find that there's a lot of information there is really about linked open data, even though it doesn't say so. So linked open data is basically referring to data that is made available for free on the web at large in the link, following the linked data principles. So there's been a movement, and unfortunately they have started, they haven't updated this chart in a long time. There was a group of people that actually were looking at the data sets that were made available and, trying to register it, list them, and put them in a graph representation, and to give you an idea of what the big cloud, the graph at large of linked open data is. So you can see the trend is definitely growing, even though some people would argue it hasn't exploded, which I think is fair. There is definitely an ongoing movement upward. So as I was saying, linked open data, however, is not all of linked data. And just because you use linked data doesn't mean it has to be freely available. The confusion was, made worse by the fact that Tim Berners-Lee, who is, a strong advocate for putting more data, making more data available for free on the web, has produced several years ago rating system with it's referred to as the STAR system with 5 different levels. It was really meant to encourage governments primarily to publish their information on the web and to make it so that it would be eventually, part of the big linked open data cloud. Unfortunately, in the first iteration of this, he even created a mug that only read linked data, and I pointed it to him. You're not making my life easier because here I am promoting linked data, and when I talk to enterprise, even inside IBM, people say, but my data is not public. There's no way I'm going to make it public, so I can't use linked data. And then I said, no, there's confusion there. And so Tim actually modified his mug, and he added the word open in there to clarify that this was not meant for everybody. And just like you can have an intranet with a website behind your firewall, you can use linked data behind the firewall too. So in fact, when you look at the different types of use of linked data, there are quite a few. There is the external ones that are part typically of the linked open data movement, primarily publishing data, but it also used to enhance visibility in search results. What I'm talking about here is, the trend with the schema.org people, who you must be aware of that. There's a vocabulary being developed by a bunch of companies, including Google, Yahoo, Microsoft, and others. And the idea is web developers can annotate their pages with semantic information, linked data information, so that the search engine can do a better job at figuring out what your page is about. People also use it to enrich the information that they publish. You have the BBC has made several communications about how they actually draw from information from the web, and it allows them to have a richer website so that when you look at, for instance, their music website, you'll have information about artists, bands, etc. And some of this information is actually drawn from the web, from the linked open data. From an internal point of view, as I was saying, you can also use it internally. The first thing is, as I was saying earlier, you can, of course, use it as the basis to do complex analysis. And, a good example of that, obviously, is IBM Watson, which you probably have heard of, and that actually does a lot of this analysis and reasoning on top of the information that it has gathered. It actually does that. It enhances the intelligence from external sources in doing that too, because it draws from a lot of the information. It sucks in, all the data clouds that it can find, including DBpedia and others. But people also use linked data to virtualize separate databases. That's a common problem. There have been quite a few presentations about that, including the SemTech conference in the past years, where people actually use linked data as a virtual layer on top of all the different databases. So let's move on. So let's get now to the problem at hand, which was to use linked data for application integration. And I want to, frame this in the context of a very specific case that triggered IBM's interest in linked data. So I actually started in the Rational product group in IBM. Rational is primarily known for developing a lot of development tools. Anything that has to do with software development is developed in this product group, and they have developed over the years many different products that allow you to manage different aspects of software development, such as of course, like version controlling, defect management, test automation, this kind of stuff. And the situation in 2000 was basically that they had a whole collection of products that worked entirely on their own, that were completely disconnected. And people complained quite rightfully that they needed them to interoperate between one another. Because in fact, they wanted to be able to say, well, when I have a defect, I'm producing a test, and this is the test going to, test that the fix actually work, and they want to be able to reference one from the other. In general, they wanted the tools to work together better. So when the Rational team started looking into solving this problem, they looked at the different ways, and quite frankly, they experimented with many different ways. And, I put on this slide the traditional ways of integrating applications. And the first one is point-to-point communication. The second one is central repository. And then the last one is a central bus. And there are proponents of these different approaches in different contexts. But at the end of the day, what we found is that none of them were really satisfactory. There's always a problem. And what we ended up in 2005, the Rational product group ended up with what was sold as the application lifecycle management solution framework, was made of a bunch of different products with a bunch of glue code that tried to connect all the different products with one another. The problem with that is it was unmanageable. People were complaining that it was not flexible enough. It was fragile because as soon as you change one product, the other fail, and that kind of information. This is the kind of problem that people were having. But also, the problem is they wanted to have more freedom to be able to integrate products from different vendors or even modules that came from them that they had developed in-house and that they wanted to integrate with the environment. And the solution that we had at the time didn't work for that at all. So that led IBM to look into other ways. And quite frankly, they started looking and thinking, well, maybe, there is a different way. And they started listing, what are the features that an ideal solution would have. And what they ended up with after several iterations is something that basically was like linked data. So they started with some in-house experiment first, and then, started using the linked data standards. So the basic idea here is that, well, instead of having each product be, have a specific interface and a way to access it, the idea is to turn each product into essentially both a server and an HTTP server and an HTTP client. When you did all the data that you have in that product is exposed as linked data and becomes accessible for other products. And vice versa, when you need to access information from another product, you can just act as an HTTP client and go access this information by connecting to the server that owns that information. Using linked data, we have the URIs that identify where the information is. We have the protocol to access it, and using RDF, we know how the information is represented so we can interpret it. This actually gives us a very flexible framework that is very resilient to change and that allows anybody to play. The only thing is you need to define the exact protocol and how you want to use the different tools, and I'm going to get to this. So, but that's the basic idea. Every product becomes a server and a client. So in this model, it's not surprising. I have a little graphic here that explains the kind of information that I was describing earlier, where you have a test case that's blocked by an issue, and the issue depends on a bug, and there's a contributor, Joe, that is committer in Apache. You have a bunch of information. This is a graph, and guess what? When you represent that in RDF with URL for every single item on this chart, you end up with a graph which can be easily represented with linked data, and where each part of the graph can be handled by a different product, a different server. That's key to this, because again, by trying to adopt a very decentralized distributed system where it doesn't matter for the test case management product which product manages issues, or for the issues management system where the bugs are. All it needs to know is it has a link, and if it follows the link, it will get the information. So I started talking about the challenges. That was the basic idea, and quite frankly, when the rational folks started going down that road, they got very excited. They were like, this is it, this is a solution. Now they started going and trying to actually do it, and they found quite a few challenges along the road. This is what eventually led IBM to come to W3C and say, hey, there's a problem here, so can we fix it? But basically, the first and foremost is that there is no formal definition of linked data. I pointed out earlier to the 4 principles that had been laid out by Tim Berners-Lee in 2006, and I did point out that it's not an official document from W3C. For all purposes, it's not, a specification either. It's just 4 principles. So it doesn't go far enough when it comes to actually implementing, a solution around those. You find yourself short in many different ways. And then when you look at the state of the art, most of what has been talked about, even in conferences and on the web, and you can, if you look into the bibliography, you can buy books about linked data and so on. You find that for the most part, the use case that is being considered is you have basically replaced your relational database by an RDF database, and then you publish this as an endpoint, typically with a SPARQL entry endpoints, which allows people to query this database, and then how this information is managed, how it is updated, or even retrieved, typically is in big lumps of data that you just update your database, and if you want, you can, some databases out there, you can do a download of the whole database, and then you import that in your personal database, and then you do what you want with it. But that doesn't fit the model that I just described, where we have a much more, dynamic environment where the information is updated constantly. That's the other part in this model, and in the model that is described by Tim Berners-Lee in his 4 principles, it's fundamentally read-only. It tells you how to access information. What it doesn't tell you is how you create the information in the first place, how you create those documents that are accessible through the HTTP with the URLs. It doesn't tell you how you find the information that's out there to start with, and there's all sorts of questions that you face when you start trying to implement an application integration framework around the 4 principles. So this is what has led us to the W3C linked data platform. As I was saying, a few years ago, IBM went to W3C and we told them we're excited, we're using this thing, linked data, here's our use case, but here are all the challenges that we faced. And W3C said, yep, we hear you. We organized a workshop with them. We invited people from the industry. The workshop was successful, well attended, and people agreed, yes, there is a gap in the W3C stack of linked data related specifications. Let's fix it. And so the W3C launched a working group in 2012, It was it was around June, and the working group has been working since then. We just passed the 2-year mark and had an extension of 6 months because we're not quite finished, as I will explain later. But basically, the idea and the charter of the group is to basically produce, a specification that will define how to use linked data in read-write mode over HTTP. And it's not meant to replace any of the other specification, but it's really meant to complement all the other specification. People have said, well, why do I need this when I have SPARQL? Well, you can use SPARQL, and with SPARQL update, you can also modify the data, but it's a different view of the information, where the information is actually accessed in the form of documents. So that leads me to talk about what's inside the LDP. And again, I am not going into the details today, but I want to give you an idea of what you would find if you start going to look into the specification. The main thing, really, and what has driven the development is starting with the 4 basic rules that were set by Tim Berners-Lee and extend on those to answer the full spectrum of questions that an application developer would face when trying to do read-write integration around the linked data. So the LDP specification defines what an LDP resource is. And basically, it tells you whether you're a server implementer or a client implementer, what to do for all of the major HTTP verbs. How you create a resource by posting, how you can modify a resource by putting or patching, how you delete a resource, and how you retrieve a resource. There is nothing really, extraordinary about that, and a lot of people say that's the only part they are interested in. It nails down some of the choices that you would have to make on your own if you wanted to just start from Tim Berners-Lee's 4 principles. And it defines exactly how you do this so that if you write an application that knows to talk to an LDP server, it can then do so with any other servers, as opposed to having to come up with your own answers to all these questions and then not having interoperability going from one implementation to the other. There is also the concept of a container that exists in the specification. It's actually, mind you, it was definitely, the part that took the most time to nail down. The idea is to, provide a basic concept. Anytime you start dealing with information, you have some form of collection that you need to work with. And rather than leaving that entirely to the application, we thought that it was useful to define some standard types of container. We actually ended up with 3 different types of containers, and believe me, as chair of this group, it wasn't my preference. I wish we had been able to all settle on one and only one container, but we ended up with 3 types of containers that were necessary to, balance both trying to have something that is super simple for the most, simple use cases, and at the same time, providing enough sophistication with the direct containers and indirect containers for more sophisticated use cases. And, you might never use one or the other. I think most people will use the basic container at least to get started, but other possibilities are there, and depending on the use case, you'll want to look at those too. We also have a different specification on paging and ordering. It was actually part of the same spec, and for reasons of trying to deal with the WG process and timing, we recently split the spec. So paging and ordering is a different specification now, and it's going its own way. But basically, it provides a mechanism to split the information into several pages. It may be impractical to retrieve all the information at once, and especially in context now we have mobile devices that are a bit more constrained. You don't necessarily want to do get of a resource and end up with several terabytes of information. So again, this is something the application could define, but there is, by defining a standard way of doing so, we are enabling interoperability from one implementation to the other. So I also wanted to give you an idea of what was going on in the working group and how things came about. So the whole group started with a specification that was actually submitted by IBM that was, largely based on the work that we had done before, and it was supported by several other companies. And the evolution of the specification, and the W3C functions in such a way that even when there is a submission and the charter points to that submission, the group is completely free to ignore the submission, trash it entirely or in parts, and this is usually pretty much what happens in working groups as soon as you have several opinionated people and with different use cases. But, for the most part, when I look at what happened to the specification, I think the specification has gained a lot in that it has basically been made more broadly applicable. And there are things like, the specification, the submission defined a set of best practices. And the working group agreed that they were good ideas and good rules for people to follow, but they were not necessary to ensure basic interoperability. So we actually moved a lot of those best practices to a separate document, but you don't need to, apply them to be compliant. One change we made was, by the time we got there, the turtle had become a standard format, a serialization format, and so we settled on defining turtle as the minimum requirement from every server and the client. In the submission, it was RDF-XML, because at the time it was the only standard available. But we recently actually added support, an encouragement to support JSON-LD. And quite frankly, there are people who say that should have been it. We should just have settled on JSON-LD instead of turtle. But that seemed to be a bit too far, and we didn't want to have to redo a lot of the things that we already done from a process point of view. It would have forced us to go back one step back into the W3C process. And a lot of the changes actually about making the specification more precise. There were a lot of maze in the spec initially. And there were some good reasons for that, because depending on the use cases, you couldn't commit to do it one way or another. And I have to say, one of the comments one of the persons who commented on the specification during the process was Tim Berners-Lee himself, and he was adamant that, if we didn't put more must, it was a useless exercise, and I think he had a good point there. So we changed a lot of maze into must and should into must. So what is the status today? The status is we published the candidate recommendation of LDP. So in June, this basically means the working group believes that it's done with the specification. We already went through a public review period, and we have accommodated all the comments that we've received. And basically now we're saying, let's make sure that it's implementable. Let's test it. So test suite was made available, and people are encouraged to test their implementation. And the idea is that as soon as there's an exit criteria, that is that we have to have 2 implementations of the specification to be able to move on. The next stage being proposed recommendation, when basically you're done. And this is just the final stage in the W3C process where the membership at large is asked to endorse the document. But so, we also published a second last call for LDP paging. As I was saying, there was some controversy about the section. This was part of the LDP spec initially, but some people were not happy with what was in the spec, and we wanted to take more time to work on it. So rather than slow down the whole specification, we put it into a different document. I can tell you that as of this morning, with the working group had a call and agreed to publish LDP paging as a second last call. So you can expect a new draft within a week or so. The main difference from the main changes that have taken place lately in the specification have to do with the negotiation of client server. Initially, the model was very much in favor of, the server is in control, period. The client has to deal with it. And now we have a system that's more flexible that allows the client and server to negotiate whether they actually want paging to take place or not. And so it provides also more certainty as to, when you go through all the pages, whether you have actually seen all the information or not, in a context where, again, we're in a distributed model where anything can change at any time, which is not so easy. We also updated the use cases and the requirements earlier this year. We just published in June a primer, and we're about to publish the best practices and guidelines document. Also about to publish the access control use cases and requirements note. This was part of the charter. Initially, when we discussed the charter of the working group, people said, well, we have to tackle the access control issue, and people say, well, if we try to do that, we won't do anything else because this is going to take us forever. All things related to security usually are really hard, and you find people with very strong opinions that are hard to, accommodate. So rather than trying to tackle it, we agreed to start the work by identifying use cases and requirements. So we have a document coming up with this. And we also started working on a patch format for linked data. I said earlier that, we had the spec tells you what to do for each HTTP verb, and that included patch. Unfortunately, this requires having a format that allows you to convey the changes, and there is no standard for this. So LDP is trying to do this. Looking forward, I'm not going to get into too much detail, but what I want to point out is that obviously we don't claim that the LDP spec, and even with paging and all the other pieces we are publishing as part of this group, the whole problem will be solved. When you look at actual application integration in the enterprise, you realize that there's a lot of other things that need to be solved. I just talked about access control, but there's also questions about validation of constraints. There is a new working group that is being proposed to W3C. I'm also involved in this. That has to do with validating data. When you start doing application integration, you're basically defining interfaces for services. If my application handles defects, you can't expect to send me a travel reservation and hope that it works. And so how do you communicate that you actually handle defects, what the defect looks like, and how do you validate this? So this is more work that needs to be done than that will be done in a different group. And then there is actually a whole series of different deployment challenges that we have faced, like this notion of the URLs don't change. We know cool URLs don't change, but the reality is they do. They do. In the enterprise, there's all sorts of reasons that make so that at some point or another your data may move, and then you have to deal with the fact that the URLs have changed. And then there are other questions when it comes to you start cloning servers and you start doing read-write. How do you handle this, etc. So this is to say this is not the answer to all of your problems either, but hopefully it will help out. Now, to try and finish, to wrap up the presentation, I want to talk about LDP implementations. There's actually, I hesitate to even put some names there because I find it's always unfair. We have a wiki page that's listed at the bottom there that allows anybody to go and, add an entry to claim that they're implementing LDP. But I wanted to point out two implementations anyway. Well, the first one is Apache Marmota, and so Apache, and so they are doing an implementation of LDP. And there's also the Eclipse Leo project, and it actually gives you a whole SDK to be able to use LDP both as a client and as a server. And as part of Eclipse Leo, there is a tutorial that shows how you can easily turn Bugzilla into an LDP server very easily. It adds just a thin layer in front of it that allows you to access Bugzilla through LDP. So it's actually pretty cool from that point of view. And Eclipse Leo is related to a bigger project that IBM has led for several years called the Open Services for Lifecycle Collaboration. And I did talk about how IBM came to use linked data for application integration. And it's clear that beyond the protocol, you also need to define, like I was saying, if we want to agree on how we're going to integrate defects with issues, well, we need to define first what is a defect, what is an issue. There is also work that needs to be done at the vocabulary level. So there is this organization, OpenServices.net, a project that is led by IBM, but has been joined by many different organizations. It's free to participate, and that looks into using this. And essentially, what we have done over the years is it started as a standalone project, and then we moved to a more standardization of the different pieces. And if you will, the idea is that the basic infrastructure, which is based on the lesson learned also, that we submit to W3C, basically constitute LDP. That's the basic layer. And then we have other groups, other technical work that has to do more with, like I said, vocabularies depending on different domains in which you use LDP. We're actually developing this at Oasis. And there's a whole member section that we started last year around OSLC, and people are invited to come and participate. It started in the application lifecycle management space, but has expanded into many other areas now, and it's a growing field. So to finish, I just wanted to, and I'm not going to get into too much detail for the sake of time, but I wanted to answer or give the beginning of an answer to a question that I sometimes get is, why would I use LDP rather than having my custom API that I used to do, where basically, I define what JSON I'm going to send you. I say you do a get on that URL, and this is the information you get. And that works well for me. And the vast majority of web apps today are written that way, and they seem to be quite content with this. So if you look at it, my point of view is it has a lot of the, if you follow this model, although it works, it very much is similar to the glue code that we talked about earlier on in the application integration that we faced at IBM. If you take the linked data platform approach, you're a much more flexible environment, a framework that allows much better integration and resilience over changes and over time. So I'm not going to spend more time on this, but I just wanted to bring that up as a food for thoughts. And I will finish with a plug for the Semantic Technology and Business Conference that's happening in San Jose next week, and where I will be presenting on LDP. It'll be more technical than this presentation in that I will actually get into a bit more of the details of what's in the specification, what it looks like. And then there is also a presentation by Sandro. Sandro is a staff member at W3C, and he has an interesting application of LDP where he uses LDP as the foundation for developing social applications. With this, I want to thank you all for joining today, and I'm happy to answer some questions if there are some.
And Arnaud, thank you so much. We do have several questions, so let's dive right in. First question that came in was, can you point to good examples of emerging business models that use LDP?
Well, the business model, I'm not sure I have the answer to that question. But I would say that if you look at the OSLC initiative, you'll find that there are many different companies that are involved in OSLC, because what they do is, in the context of ALM or PLM or others, they actually are able to play in this ecosystem where products are not linked through proprietary APIs anymore, but through some standard API. And it allows them to develop components that augment the solution that are being offered by vendors like IBM. So I think this is proof that, there is an opportunity for people to play in that, which you don't have otherwise.
Okay. Our next question may be more a question about REST rather than LDP, but what should be considered a representation of a resource, and what would be a new resource? For example, I can understand Turtle and JSON-LD might be different representations of a resource. But what if I have an image and the client requests an RDF representation of the image, that is the metadata? Is that a representation or a separate resource?
Okay, so that's a good question that talks about, obviously not everything can be represented in RDF, and an image is a good example. So I did say that, LDP defines an LDP resource. In fact, this is a type. There are different subclasses. One is an RDF source, so that's for actually documents that contain RDF, and then there is and we struggle with the name, but it's basically an LDP non-RDF source that encompasses anything that's not RDF. We've commonly referred to these as the binary resources, and it was really just a code name for anything that's not RDF, because if you have a piece of XML or HTML for that matter, it's not RDF either. And so what the LDP specification provides is a way to manage those as part of the LDP model in general. And so essentially, for instance, what it does is specify that when you want to create an image, you will post the image to the server. What the server is going to do really is going to create two resources, not one. It's going to create one resource with the content of the image, which is binary, and then it will create another resource, which is in RDF, which contains the metadata. And they actually link to each other. And the specification defines how this is done and how you find the two resources, so that this problem is actually answered. And so there are two resources in this case. And, the metadata is typically things like who created the image, when it was posted, that kind of stuff, right? That can be all expressed in RDF, and some of these properties are actually managed by the server itself. So it makes sense for the server to create this.
Sure.
And the way you link these things, is typically something that there are many different ways you could do it. For instance, we had discussions about which one is returned as part of the post. Is it the binary? Is it the RDF? And so the specification answers all these questions so that we can all do it the same way and have interoperability.
Okay. Our next question is, are other major technology companies, for example, Oracle, SAP, Siemens, embracing LDP? You mentioned some of the initial sponsors, I think back around slide 2021. But are you aware of other major technology companies that you would say are embracing LDP?
Yeah, so Oracle is definitely part of the working group. They've remained part of the working group, and they're, so they are committed to supporting LDP. If you look at OSLC, a lot of the people are actually using it. We have a lot of companies involved in OSLC, but they are more interested in the higher level, so their interest is somewhat indirect. And this is often the case in W3C standards activities is, there are only so many vendors that are interested in the gory details. Most of the people are interested more in the application layer that will come on top of this. So Siemens was part of it initially. At this point, I don't know if they, whether they will implement it or not. I think this year is out. And so we are actually in the process, like I said, of gathering implementation reports. We'll have to see who, shows up with an implementation. That's when we'll get the real answer to that question.
Yeah. All right, next question. How does LDP Container differ from SPARQL at finding existing things?
So the difference is that, in SPARQL, it's a very flexible query language, and it allows you to, query according to all sorts of different criteria. In the case of LDP containers, it allows the server to organize the information in form of collections, if you will. And that's the way the information is represented to the client. And, the analogy that a lot of people use, although it has flaws and they are risking sticking to that too much, is, resources are files and containers are directories. And if you think of LDP as a protocol to access a remote file system, you think, well, containers are a form of directories. And so there are other ways you can, of course, query the information, and you may want, for different reasons, want to see the information in different ways. But this is one way where the application on the server side, can organize the information without the client having to figure it out. So it's fundamentally a different way of accessing the information.
Okay.
I don't know if I answered the question well, but I think you have to look into it and kind of practice it to try and figure exactly where the subtlety is.
Yeah, and there was actually just a follow-up question posted comparing, can you compare a container versus a triple store?
Yeah, so that's a bit easier. I mean, again, it's like, in a triple store, so depending on the kind of triple store, triples are all part of the same graph. And then you can have data sets that allow to have basically several graphs that are named independently from one another. But, the container is the graph on its own. The LDP container allows you to have a much smaller unit of containment, which only contains a few nodes in a bigger graph.
Okay. We have time for one more question, and this is actually a really good one to wrap up on. Is the deployment guide and the specifications for this available at W3C, which is w3.org, or where?
Yes, absolutely. I guess I should have had the link somewhere.
Well, no, I can help a bit
yes.
with that because one of the reasons this is a good one to wrap up on is I want to let everyone know we will post a link to that alongside the link to the slides and to the recording of this webinar when we post this on Wednesday of this week. So at this point, thank you all very much for your wonderful questions. I'm sorry we didn't have time to get to all of them, but appreciate you tuning in and appreciate your attention during this hour. Arnaud Laors, thank you so much for this great presentation and Q&A. I'm afraid that is all the time we have for today. Just to remind everyone, we will be posting the recorded webinar and slides to SemanticWeb.com within 2 business days. And I will send out a follow-up email to let you know the links and other requested information. Also, don't miss your chance to meet Arnaud and Sandro Hawk from W3C in person at the 2014 Semantic Technology and Business Conference, where they will be giving the presentations that you see on your screen now, and we'll be diving deeper into the linked data platform. If you are coming to the conference, bring your questions and discussion points. It's always a good time to dive deep into the specifications. Thank you again for attending today's webinar, and I hope you all have a great day.
Thank you for having me, and thank you all for joining.
Absolutely. Thank you.